Okay, this is the last recitation we missed. So I'm going to talk about here. This is also for your final exam practice. So the first question is graphing. So A, we see this polynomial, right? So one piece of string, polynomial function, and the end behavior going to infinity, we see from two ends. Let me mark here. So we see on the left-hand side, this keeps going, right? We can put an arrow on it. On the right-hand side, we can put an arrow on it. So it means, the graph just keeps growing. So we know the leading coefficient is positive. And also we know this is the degree of even. Okay. So what do? We write f of x equals to, we just count how many roots. We see -5 is a root, so we write as x minus -5 becomes x plus 5. Then we see at the origin, we see the graph wiggles, right? That means we have x cubed. Remember, wiggles means x cubed. Then, so that means also means x equals 0 is a root. It's a root with a multiplicity of 3. Then we see 6. At 6, it's multiplicity of 2, if you remember. So we make a square term. So this is just, we just write down one of the equations, right? It goes from the origin 0, 0. So that means x is a factor. And then the graph wiggles at the origin. That means the multiplicity is of 3. Then we see -5 is a root. So we have x plus 5. The 6 is a double root, means multiplicity of 2. So we have x minus 6 squared. So that's the function for the first graph. For the second graph, okay, I'm going to erase all this. For the second one, we have rational function, right? We have rational function. And first we observe y equals 0, which means the x-axis is a horizontal asymptote. That means the degree in the numerator is lower than the degree in denominator, right? And then we check, we have two vertical asymptotes. We have x minus -3, so -3, x equals -3 is a vertical asymptote. That means in the denominator, we have x minus -3 becomes x plus 3. Then what else we have? We see 4. X equals 4 is another vertical asymptote. So that means x minus 4 also in the denominator. Right? Because those ones in the denominator creates asymptotes. So this is the function for this graph. Now let's go to 2. 2, solving inequalities. So we have 3 factors here. The second factor doesn't really contribute anything because it's positive. But it's positive. And also we're talking about the greater than 0. So we can leave this one out. You don't need to think about this one, right? Because it will never be negative. So it goes along with this positive sign, the greater sign. So we only consider those 2 factors, x plus 5 and x minus 4 cube. X minus 4 cube, we can treat it as x minus 4 raised by 1, right? Because 1 is odd, cube is odd, they're both odd. And all we have to consider is a sign, the signs. So plus, plus, or minus, minus. Or we draw this, we draw a real number line. We mark 0 somewhere. We mark 4, because we have x minus 4. x plus 5, we want to mark a -5. Right? So we split this into 3 intervals, from -5 down to -infinity as one interval, in between -5 and 4 as another interval, then from 4 to positive infinity as third interval. So we split into third intervals. Why? Because we want to pick a value from here, then try in the inequality. Well, let's pick 0. So 0 is in the middle interval from -5 to 4. So let's plug in 0 to see what happens. If x equals 0, this is the first one is 5, positive. X equals 0, the second one, 0 minus -4, 0 minus 4 becomes -4, -4 cubed still negative. So this one not in the solution. But this 0 represents the interval of -5 to 4. So that means this interval from -5 to 4 is not a solution for this set. Now let's pick a value, let's say -6, the first interval. -6 plus 5 will get negative. -6 minus 4 will get negative. Negative raised by cube, still negative. Negative times negative, positive, yes. So this interval in the solution set. Now let's pick 5 from the third interval. Right? 5 plus 5, positive. 5 minus 4, positive. Positive cubic, positive. Positive times positive, yes, positive. Still greater than 0. So that means this one also in the solution set. Now we can write our solution set. So our solution set will be down from -infinity. I'm going to write as a word. Okay. The sleeping 8. Down to from -infinity up to -5 with close parentheses, right? Because you see the inequality doesn't have an equal sign. Then union from +4 up to positive infinity, right? My keyboard doesn't have the infinity sign, so I use the word infinity. Okay, so the solution is a union of two sets, from -infinity up to -5, and from 4 up to positive infinity. Okay, the 2a, now let's see 2b. 2b, we will solve this trigonometry equation for the solution sets in this interval from 0 to 2 pi. Okay, for this, we have the different angles. The first sign has 2x as an angle. The second one only has x as an angle. So if we remember something called a double angle formula, so we can rewrite this as the sine of 2x as 2 sine x cosine x. So the angle now is x, right? So our angles are consistent now. And also the two terms, we have a common factor of sine of x. Now we want to factor out sine x. Then we have 2 cosine x for the first term, then 1 for the second term, that equals 0. So we're able to write this two terms into one term with two factors. So 0 property is saying if the product equals 0, each factor can be 0. That means sine x can be 0 and 2 cosine x plus 1 can be 0. So solve those two equations. We think, okay, when do we get sine x to be 0? What does the angle have to be? First, the angle is 0, right? If the angle is 0, sine 0 equals 0. Then in the interval from 0 to 2 pi, we also see pi. Right? So we have two solutions for sine of x. 0, sine 0 is 0, sine pi is 0. I don't have the letter pi, so I'm using the word pi. Let's see the second equation. 2 cosine x plus 1, that means 2 cosine x equals to -1. or cosine, I'm going to write on the top here, okay? Cosine x equals to -half. Now we need to think. Cosine being half in which quadrant? In second and the third quadrant, right? Cosine value to be positive in the first quadrant and the fourth quadrant. But in the second and third quadrant, cosine value is negative. And remember cosine, which angle equals to half? Cosine 60, right? Which is a cosine pi over 3. So, but that's a reference angle. So in the second quadrant, imagine the triangle. Our true angle is pi minus pi over 6, right? Which is 5 pi over 6. So this is a solution in the second quadrant, right? Solution in the second quadrant. Then in the third quadrant, the angle is pi plus 5 pi over 6, or 5 over 6 pi, right? So which is 11 pi. Oh, why do I have 5 here? Pi over 6, which is 7 pi over 6. Okay, so I have 4 solutions. Oh, not only 4. Yes, I do have 4 solutions. So the angle can be 0 and pi. And also the angle can be these two. 5 pi over 6 or 7 pi over 6. So 4 solutions for this. Now let's see question 3. Question 3, we want to find our roots, right? Real roots and complex roots for this polynomial, degree 4. So what do? You may use a long division, but here I want to do short division because short division is so quick. Short division, I only have to write the coefficient of each term. Oh, why write 4 here? I just need a 1, right? I just need to write down the coefficient. So 1, because this is a 1. So 3, x cubed coefficient is 3. The x squared coefficient is -7. X coefficient is -7. Then 2. Now remember the root theorem of roots. By saying all the roots of a polynomial come from the division or the quotient of the factors of the constant term and the factors of the leading coefficient. Well, for us, there's only 2 possibilities because the factors of 2 is the 1 and 2 with a plus minus, right? The factor of 1 is plus minus 1. So if I do plus minus 2 divided by plus minus 1, I get a plus minus 2. If I do plus minus 1 divided by plus minus 1, I get a plus minus 1. You know, so possibly these 4 roots. So let's just try one by one. Well, let's try 1 first. Let's try 1. So first step, I pull down this 1, then multiply those 2. 1 times 1, I leave here. Then I add those 3 to 1, I get 4. Then I multiply 1 with 4, I put 4 here. Add those 2, I get -3. Then I multiply -3 with 1. Each time I multiply by this 1, I get -3. I add these 2, I get -10. Oh, I see this. Okay, -10 times 1, that's a -10. Then when I add those 2, I get -8. Well, it's not 0. Right? So that means 1 is not a root. X minus 1 is not a factor of this. Well, let's try -1. Right? Let's try -1. So I get 1, 3, -7, -7. Let's try -1. Then, oh, this is a +2. Why I read it -1 here? This is +2. Now let's try -1. I still pull this 1 down. I multiply -1 with 1, I get -1. I add 3 with the -1, I get 2. 2 times -1, I get -2. Add -2 and -7, I get -9. -1 times -9, I get a +9. I add those two, I get a +2. 2 times -1, I get -2. -2 plus 2, bingo, 0, right? So that means -1 is a root. -1 is a root. Now let's keep trying. Keep trying. -1, or maybe should we try 2? Sometimes we could try -1 again, but let's try 2. Or maybe try one more time -1 to see it works. So see, if we get an x -1 to the square, which means -1 is a root with multiplicity of 2. So I still pull this one down. -1 times 1, I get -1. Add those two, I get 1. -1 times 1, I get -1. Oh, this one is not, right? I get 10, so it's not. Well, let's try 2. 2, I pull this one down. So 2 times 1, that's 2. 2 plus 2, that's 5. 2 times 5, that's 10. 10 plus 9, 10 minus 9, that's 1. 2 times 1, that's +2, right? What if I do -2? I still pull this one down. -2 times 1, that's -2. -2 plus 2, that's a 0. 0 times -2, that's a 0. Oh, that's also not. All right, let's see. Let's write it. Maybe we get, so we can rewrite f of x equals to, since we know x minus 1 is a root, we can write x plus 1 times x squared. I'm going to tell you where is my x squared come from. X squared plus 2x, not x squared, x cubed. X cubed plus 2x squared minus 9x, then plus 2. Right. So far, we write the equation as this. X plus 1 times x raised by 3 plus 2x squared minus 9x plus 2. So we tried -1 already. -1, -2. Right, none of them works. So now we have to think about complex roots. Can this be factored? Let's see. No, I don't see the possibility of factoring. So -1 times 1, -1. Then plus we get 2, -1 times 2, -2. -2 plus that, -9. -9 times -1, +9. Then +2. Then -2 plus 2, 0. Yes. So none of them work anymore, right? So we need to find complex roots. How do we find the complex roots for this? I was thinking maybe we should be able to find another root. Let's try one more time to see if it's possible. Right. So see if it's possible. So let me use the red color. So we tried -2. Did we try 2? I forgot. Did we try 2? We tried 2, right? We tried 2. Because we should be able to get another solution from this. Right? Because we still have a cube. We still have to a third degree. To a third degree, we have no ways to find the complex roots. If down to quadratic, we're able to use quadratic formula to find the roots. Sometimes the roots can be in many complex numbers. So we need to do one more layer to get down to quadratic. But this -9 is really big. Do you see that? Right. So let's try 2 again. So 1 times 2, that's +2. 2 plus 2, that's 4. 2 times 4, that's 8. Oh, this one works. The -9 plus 8, -1. -1 times 2, -2. Bingo. 2 plus -2 is 0. Once we get a 0 in the end, we know that's a factor. Okay, let's rewrite this. So we got 2 factors now. We have x plus 1 and x minus 2. Now what's the rest? The rest comes from here. You see 1, 4, -1 down here. 1 represents 1x squared. And the 4 means 4x. What is coefficient for x? Then -1, that's a constant term. Because each time when we do short division, the degree lowest one degree down. This is x to the 4th power. Right. This one. Then down here, this x cubed, x to the 3rd power. Then down here is x squared. So each time the degree lowered 1. So I have x squared plus 4x minus 1. Now we know this doesn't, x squared plus 4x minus 1 cannot be factored. So we use quadratic formula. Quadratic formula, we have negative b plus minus square root of b squared minus 4ac divided by 2a, right? A is the number before x squared, in this case it was 1. B is the number before x, in this case is 4. So I have -4 plus and minus square root, I'm going to write this way. Square root b squared, which is 4 squared 16, minus 4ac. 4 times 1 is 1, 4 times negative 4 times -1 is positive 1. So 16 plus 4 gets square root of 20. Square root 20 can be simplified, right? Because square root 20 can be split as a square root 4, square root 5, square root of 4 is 2. So that becomes 2 radical 5. So that's square root of 20 becomes 2 times square root of 5. Then this all divided by 2a. A is 1, so it's divided by 2. And this can be simplified. -4 divided by 2, this is -2. Plus or minus. Complex roots come in pairs, like irrational roots come in pairs too. 2 divided by 2 just becomes 1, so I have a square root of 5. The golden ratio. You see the golden ratio? Not exactly, right? Because we don't have divided by 2 anymore. So how do we write this? Square root of 5 it's not complex, it's irrational, right? Irrational, so square root of 5, irrational roots. But how do we write it? We write it like this, f of x, of course we start with f of x, equals to, the real roots will have x plus 1 times x minus 2. Now we have x minus 2 plus square root of 5. You see that? Right. And then we have x, minus 2 minus x minus 2 minus square root of 5. Irrational roots come in pairs. Complex roots come in pairs. So that's it. This is a solution for this one. Find all the roots, real and complex. Oh, she doesn't really want us to write in the factored form. So we identify like this. The roots is -1, +2, then those two. Right, we have 4 roots. -1 and 2 and -1 plus square root of 5 and -2 minus square root of 5. So you get 4 roots. Let's see B. We want to use a binomial theorem expansion to expand this. I remember in my last video, I used Pascal's triangle. Do you remember Pascal's triangle? You build the coefficient of that, right? You start with 1, that's your level 0. Then you build the 2, 1 on the side. That's your level 1. Then You keep building, you keep putting 1, but then these 2 ones adds up to be 2. So this is your third level. You still have 2 1 on the side. You keep putting 1s on both ends. But the middle part you add. So 1 plus 2, you get 3. 2 plus 1, you get 3. Right, so we have a 0 level, first level, second level, third level, let's do fourth level. 1, these 2 adds up to be 4. These 2 adds up to be 6. These 2 adds up to be 4 again. Then we put a 1 in the end. So we started with 1, we end with 1. Now let's keep doing one more level. So this level now, it should be 5th level. Oh, we don't need a 5th level because we only have 4. N equals 4. So the first one means n equals 0, n equals 1, n equals 2, n equals 3, n equals 4. So this is the coefficient for n equals 4. But that's the only coefficient of the term, 5 terms, right? Raised by 5 power of 4, we have 5 terms. Then we have to remember the first one, starting with exponent 4 and decreasing each time, decreasing by 1. So first term we have x raised by 4, second term we have x raised by 3, third term we have x squared, fourth term we have x raised by 1, fifth term nothing. The second one goes ascending order. So the first one goes descending, right? The exponent from 4, 3, 2, 1, and 0. The second one goes ascending order. So the first term we won't see it, second term we'll have to see 5y, parentheses, raised by 1, then parentheses 5y raised by 2, then raised by 3, then raised by 4. All right, so let's do this. So that means this, so the first one we have x raised by 4. Coefficient of 1, we don't bother to write it. Plus the second term has coefficient 4, then multiply by the first one, x raised by 3 now. And the 5y, because we're treating 5y as one term, 5y raised by 1, right? Then we can simplify. 4 times 5 is 20. So 20, x raised by 3, and then y raised by 1, y raised by first power. Okay, write this way. So the first term is x to the fourth power. Second term is 20x cubed y1. Well, let's keep writing it. So the third term, we have plus. Now x becomes x squared, right? We have x to the fourth power, x to the third power, now x squared. But then the second term, 5y, now we have to the square, right? 5y to the square. Think about the a plus b raised by 4, right? So 5 squared is 25. We like to write up front as coefficient, 25. Then we just have y squared, right? So the third term is 25 times x squared, y squared. 2 more terms, plus fourth term. Fourth term now we only have x, because we had x to the fourth power, x to the third power, x squared, now it's x. Then times the second term, 5y raised by 3. 5 raised by 3, that's 125, right? And then y raised by 3, that's y raised by 3. So the fourth term, we have 125 times x, y raised by 3. Now last term. Last term, we don't see x anymore. Basically, we do have x raised by 0, but which is just 1, so we don't bother to write it. But then the second term, 5y raised by 4. Right? Second term is 5y raised by 4. What's 5 raised by 4? 5 raised by square is 25. 25 times 25, what is it? 225. Let me double check. what I remember is 25. Oh, my head, get to the evening time doesn't work. 25 times 625, not 225. 225 is 15 squared. 625, y raised by 4. So 5 raised by 4 is 625. Y raised by 4 is y raised by 4. Okay, so these are the 5 terms. Okay, are the 5 terms of this expansion. X plus 5y raised by 4th power should have 5 terms, right? So this 4 is n. The term should have n plus 1 terms. Now let's see 4. This summation signs. Right, we want to find the sum of this. So we don't need to simplify. Let's see, how do we do this? Well, starting from 6, right? So we have 54. We can leave 54 outside because 54 is a factor of everybody. Because I have 2 raised by k minus 1. So k, we start with 6. 6 minus 1, which is 6 raised by 5. Then the second term, we know already. Actually, it's 2 raised by 6. Right? Because each time, we just increase them by 1. Because now we have 7 minus 1, which is 6, until 11. Then we have 2 raised by 7 plus 2 raised by 8 plus 2 raised by 9 plus 2 raised by 10. Now we're finished because the last one, our upper limit is 11. 11 minus 1, which is 10. So we have this. Now let's only think about this one. Let me change my color. Let me only think about the inside the parentheses. I actually have a video. I put up so many videos on my YouTube channel. And one of the videos to show you how to calculate things like this, right? So let's forget about 55 for a moment. Let's just calculate this. Let's call this S, like a sum. So what do we want to do? We want to do 2S, 2 times S. So if we do 2 times S, we see everyone, the exponent of everyone being increased. But 2 raised by 6, until the last one changes to be 2 raised by 11, right? 2 raised by 10 times 2 becomes 2 raised by 11. 2 times 2 raised by 9 times 2 becomes 2 raised by 10. So that's my 2S. I basically multiply by 2 with every term. Then I do 2S minus S. So 2S minus S is still S, right? But when I do minus, you see those 2 canceled, 2 to the 7 canceled, 2 to the 8th canceled, 2 to the 9th canceled, 2 to the 10th canceled. I'm left with a 2 raised by 11 minus 2 raised by 5, right? Then multiply by 54. So yeah, let me remind you, if you want to become a little better with mathematics, watch my video, all right? I have put up many videos to teach you how to calculate, how to do how to get to the solutions, in the easier way, like solve equations, all right? So we don't have to simplify this. We just, the answer is 54 times 2 to the 11th power minus 2 to the 5th power. Okay, that's this one. Now let's see B. We want to write we want to expand completely, okay? So numerator, we get positive terms. Exponent becomes the coefficient before logs. So we write as log base 2. Log base 2, actually we can write as LG, right? The numerator, we have y cubed. That's 3 log base 2 of y, right? Then plus log base 2 of square root of x minus 1, which is, you see, we have a half in front of a log. And the square root of x minus 1, we need to put, or we don't need to, because it's inside square root. We just put parentheses x minus 1. So that's our numerator. Now denominator are negatives. Right, so denominator we have a log base 2 of z, then minus log base 2 of y squared plus 1. And that's it. How many terms we have? Let's count. We have 3 log base 2 of y that comes from this. We have a half log base 2 of x minus 1. That's from this one. Both in numerator, so they're both positive. Now let's see this one, log base 2 of z. That's from this one, because in the denominator, so it's a negative. Then we have this term, y squared plus 1. That's log base 2 of y squared plus 1, negative, because it's in the denominator. Can we split y squared plus 1? No more, no. So y squared plus 1 has to be together. Has to be one term, because it's not a multiplication. If it's a multiplication, we can split into 2 logs. But if it's a subtraction or addition, you know, it cannot be split, just this. Let's see 5. Oh, 5 is the last one, actually. 5, we need to verify. Verify. It's like a proof. So what do? We want to start from one side, then end up. So start from one side, end up with the other side. All right. So this is our goal. We wanted to go through something. We want this to go through something, simplify, simplify, simplify. In the end, get sine square x. Okay. So secant square x, I have to write this, I guess. Secant square of x minus 1, if you remember, that's tangent. Okay, secant square equals 1 plus tangent square, right? So secant square minus 1. So tangent square, let me write on the side. So secant square x equals to 1 plus tangent square x. But we have secant square minus 1. So we move 1 to the other side, we see that's tangent square. Right? So let's write down. So we have a tangent square x in the numerator. Now the denominator. Oh, actually, you know what? Let's not go through this way. Let's go through the other way. The other way is much easier. You see this? We just split. We get 1. Something divides itself, we get 1. Then 1 minus 1 over secant square. Remember what's 1 over secant? Cosine, right? So simplify this. Secant square divided by secant square, we get 1. Then minus 1 divided by secant square, which is 1 minus 1. So 1 over secant is cosine. 1 over secant square is cosine square. 1 minus cosine square indeed is sine square. That's it. Okay, this one is very easy. 2 steps. All right, that's all for the last recitation, which we missed. All right, good luck.